Hello, boys and girls. I hope everyone is doing well. Today in these notes, we're going to go over compound probability as well as the counting principle. I have several examples to do with you for compound probability because it is a challenging skill. I've also posted a video in Edpuzzle that I would highly recommend that you watch on compound probability. Okay, so the first slide is basically just your formulas for compound probability. Many questions you'll see with the word and, the probability of A and B happening, and then some probability problems you may see the probability of A or B happening, which is this one down here. So if we're using the and word, two events happening, then multiplication happens between the two events. If we're using the or word, the probability of A or B, it would be an addition problem. And we'll do several examples together so that you understand the difference between the two. We're going to be focusing on independent events. You'll learn when you get into 8th and 9th grade that there's independent and dependent events. In 7th grade, we're only focusing on independent events. And what that means is that the outcome of one event does not affect the outcome of another. So as you can see, I've got two spinners. One has 3 colors on it and the other has the numbers 1 through 4. So the probability of, let's say, getting a red on the first one has no effect on the probability of getting a 2 on the other spinner, which makes it an independent event. If you spin the green on spinner 1, it does not affect what you spin on spinner 2. Okay, so here are a few examples. It says one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Okay, well, the first example says the probability of selecting a vowel. If you look at the letters given, you can see that there's E and A, so you have 2 total vowels. 2 is on top. And then there's 1, 2, 3, 4, 5, 6, 7 total letters. So the probability of selecting a vowel would be 2 out of 7. That would be one event. The next one is the probability of spinning a vowel. Well, let's look on this spinner. You've got 6 total letters. And then how many vowels do we have? We have 2. So that would be 2 out of 6, which simplifies to 1/3. Now the probability, this is where it becomes a compound event. Each of these were simple probability problems because it was one event, but now it becomes a compound probability because there's 2 events happening. Probability that both letters are vowels, well, we're just going to take the probability from the first one and the probability from the second one and multiply those together. And you can see 2 times 1 gives you 2, which is your numerator, and 7 times 3 gives you 21, which is your denominator. So the probability that you get a vowel on both events is 2 out of 21. Okay, what is the probability of spinning a green and getting an odd number? Remember, compound probability is equal to the probability of the first event multiplied by the probability of the second event. So the probability of a green, well, there's 3 sections on the spinner, so the probability of green would be 1/3. And the probability of an odd number, well, your odd numbers are 1 and 3, so that would be 2 out of 4, which simplifies to 1/2. So to find the compound probability of both events, you're just going to multiply your 2 probabilities together. So 1/3 times 1/2 equals 1/6. What is the probability of flipping ahead and then rolling a factor of 6? Okay, so the probability of flipping ahead, well, think about it. On a coin, it's heads or tails, so the probability of getting a heads is 1/2. And on a number cube, a factor of 6, well, first you have to think of your factors of 6. I have them listed out here. 1 and 6 would be a factor of 6. And then 2 and 3 would be a factor of 6. So that would be 4 out of 6 numbers on the number cube, which simplifies to 2/3. And then up here, you can see I'm just taking my 2 probabilities, 1/2 for flipping a heads, and multiplying it by 2/3, which was the probability of getting a factor of 6. I've cross-simplified my 2's to be 1's, and that's going to leave us with a probability of 1/3. Okay, what is the probability that you roll a number cube and flip a coin? What is the probability that you get a 3 and a tails? Well, on a number cube, you've got 6 numbers. So the probability of getting a 3 would be 1 out of 6. There's only 1 3 on a number cube. And the probability of getting tails is 1/2. So 1/6 times 1/2 gives you a compound probability of 1/12. If you flip 3 fair coins, what is the probability that you'll get a head on the first flip, a tail on the second flip, and another head on the third flip? Well, as you can see, I've drawn a tree diagram. We discussed these in one of the previous lessons on sample spaces. So if you're flipping a coin 3 times, you can get heads or tails. Then the second flip, let's say you hypothetically flipped a heads the first time, you can get heads or tails again. So this second row represents the second flip, and then this bottom row represents your third flip. If you notice, if I count all these outcomes, there's 8 total outcomes when you flip 3 coins. So they said, what's the probability that you get a head on the first flip? So as you can see, my cursor's on the head, then a tails, and then another head. Well, that's going to be one out of 8 total outcomes, giving you a probability of 1/8. You choose a tile at random from the game tiles shown. You replace the first tile and then choose again. What is the probability that you choose a dotted tile and then a dragon tile? Well, as you can see, we have 15 total tiles here. So the probability of choosing a dotted tile, well, we've got 1, 2, 3, 4 of them. So 4 out of 15 times, we're putting it back in, which means we still have 15 tiles. And then the probability of a dragon tile would be 1, 2, 3 dragons. So 3 out of 15. So 4/15 times 3/15, as you can see, you can cross simplify with your 3 and your 15. They're both divisible by 3, leaving me with a 1 up top and a 5 on the bottom. And then we're just going to multiply across. 4 times 1 gives me 4, and 5 times 15 gives me 75. So your compound probability would be 4 out of 75. Okay, picking a ball from each jar. What is the probability of picking a red ball from jar 1 and a green ball from jar 2? Notice the end word, meaning compound probability, which means multiplication. So the red ball would be 2 out of 5, and a green ball would be 1 out of 4. I can cross simplify by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And that's going to leave me with a compound probability of 1/10. 1 times 1 is 1, and 5 times 2 is 10. What's the probability of picking a yellow ball from jar 1 and a yellow ball from jar 2? Well, a yellow ball from jar 1 would be 2 out of 5, and a yellow ball from jar 2 would be 3 out of 4. I can cross simplify with my 2's again. I can divide both of them by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And that leaves me with 1 times 3, which is 3, and 5 times 2, which is 10, giving me a compound probability of 3/10. James lives in San Francisco and works in Mountain View. In the morning, he has 3 transportation options, bus, cab, or train to work. And in the evening, he has the same 3 choices for his trip home. If James randomly chooses his ride in the morning and in the evening, what is the probability that he'll take the same mode of transportation twice? Again, I drew a tree diagram. So his options in the morning are bus, cab, or train. And then from each of those, there should be 3 branches for bus, cab, or train. So the question's asking, what is the probability that he'll take the same mode of transportation twice? That means he'd have to do bus, bus. Notice I've circled that. Cab, cab. I've circled that. And train, train, which I've circled as well. So that is 3 out of 9 total possible outcomes. It's 9 outcomes because if you count all your bottom branches, there are 9 options. And 3 out of 9 simplifies to 1/3. So the compound probability would be 1/3. Okay, what is the probability of rolling a 1 on the black die and an even number on the white die? Well, as you can see, we've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's 24 total outcomes. And we want to find the probability of rolling a 1 on the black die and an even number on the white die. So if it's got to be a 1 on the black die, we're only looking at this first column here. And we're looking for an even number on the white die. So that would make this a favorable outcome and this also a favorable outcome. So that would be a compound probability of 2 over 24, which simplifies to 1/12. Okay, moving along to the counting principle. This one's a much easier skill than compound probability. There's a lot on this screen, but basically all that it's saying is if you have m possible outcomes for one thing and n possible outcomes for the other, to find the total possible outcomes, all you're doing is just multiplying them together. So let's take a look at this example. A sandwich cart offers the choice of hamburger, chicken, or fish on plain or sesame bun. How many combinations of meat and bun are possible? Well, you have 3 choices for meat and 2 choices for buns. So the total possible combinations, 3 times 2 is 6. Okay, here they're asking how many combinations. Well, you have 3 sandwich choices, 2 soup choices, and 4 beverage choices. So all you're doing is just multiplying those 3 numbers together. 3 times 2 is 6. 6 times 4 is 24 possible combinations. Bruce and Krista are going to buy a new furniture set for their living room. They want to buy a couch, a coffee table, and a recliner. They have narrowed it down so that they are choosing between 4 couches, 5 coffee tables, and 9 recliners. So 4 times 5 times 9. 4 times 5 is 20, and 20 times 9 gives you 180 possible combinations. Sebastian is going to choose the color, pattern, font, and image for the design of a sweatshirt for his dance team. There are 10 colors, 4 patterns, 12 fonts, and 9 images for him to choose from. The printing company charges a fee to add extra design elements, so he will choose only one of each. How many different sweatshirt designs are possible? Well, all you're doing is just multiplying 10 times 4 times 12 times 9, which gives you 4,320 possible combinations. Okay, the note-taking packet pages that correlate to these 2 skills are pages 11 through 14, top of the page. Again, feel free to watch the videos in Khan Academy if you would like to see additional examples. I will be posting the answers from the note-taking packet on Google Classroom, and feel free to ask any questions via email, the Google chat, or the Zoom session this week. Have a nice day, everyone.